Hi guys, and welcome to part 3 of the C++ and Visual Studio Primer by Datatypes Rust. In the previous episodes we've done the intro, the project creation, we've done some includes, and we've done the hello YouTube for the canonical sort of initial programming structure. So now in this episode we're going to deal with data types and the sizes of the data types. So first we're going to talk about data types a little bit and do a little bit of show and tell if you like. So I'll start with a character data type. So I'll make a new variable called C of the character data type. I'll assign a capital A to it. So the character data type holds a single character. Now I'm going to comment out this current CO and we'll make a new one. Right, this one's going to just output an A. So it's taking the character data type variable of C and outputting the content of it, which is A, to the screen. So if I save this and run it, we should have a A and pressing the key to continue on the screen. So it's fairly straightforward, it's not anything too mad. It's just building it, compiling it and stuff. Okay, that's almost ran and we're running. And there we go, we have an A. So it's taken the variable and popped it out onto the screen. But that's the character data type. You can hold a single character in the character data type. Next is the short. Short S equals 23. We'll go with that. Short's a short integer. It's 16-bit integer, I think, in most systems. So basically 2-byte integer. I will sort of deal with SizeOf soon, but right now I just want to get through a few of these things. So again, we're going to do the std cout. Yes. Headline. So this is just going to basically display a 23. So if I save this, I'm not going to just run every single one when I say these things. I just want to iterate and show you these to reiterate the actual fact that they are doing what they say they're doing. So it's building it. Going to run through. And there we go, it's got an A and 23. An A and a 23. Now, that's the two. I'm going to fill in a few more, like int I equals 230,000 and a, let's say a long int, will that do? Maybe a long int or a long. I'll try long int. I can't remember whether that works out correctly or not, but we'll find out in a moment. Let's do it as 2 billion. What's next? Next we'll do a floating point one. A float f equals 12.2. Yeah. Oh, f to denote that it's a float. Then we have a double precision floating point number. That's basically double the size of a float, as in size wise as to what it can actually hold, but we'll get into that as we go. 2 byte integer value. I believe it's 2 byte. I'll check on that as we go, but maybe 4 byte integer value. Long int I think is an 8 byte. But we'll check on that because I may have to actually change that to longer rather than long int, but we'll find out in a moment. A float is just a single precision floating point number, and then double is basically the same as a float but double the size. Okay, so now we're going to copy and paste this a few times to save me typing it. Look, how many have we got? 1, 2, 3, 4, 5, 6 different ones there. 6, there we go. Now let's do an I, we'll do a L, do a F, and do a D, just so that we can kind of display them to the screen. Okay, so we're going to have basically these values displayed to the screen. Now there's 2 billion. If I've done this correctly, 2 billion should show fine. Shouldn't be an issue. If I've done it incorrectly, it should not show the correct number there. So we'll find out that in a minute. Okay, that's compiling. Okay, it showed the 2 billion perfectly fine. Let's have a look what else we've got. That seems to have shown everything correct, isn't it? Ooh, the double's only showing 1 decimal place at the end. That's rather an interesting one. Okay, but we'll have a look at that at some point because that seems to have capped that off a bit, hasn't it? But we'll see how that goes. I think formatting may actually allow you to add more decimal places to that, but we'll see how that goes. Okay, so now if that's what that's done, there's a couple more things. There's like a bool for boolean equals true. There we go. It's basically a logic data type that can hold either true or false. I believe in C and C++ it actually holds an integer of 0 or 1. Anything that's not a 0 is counted as a 1. Hence true. So basically a non-zero value is true, a 0 value is false. Okay, that seems to be a fair amount of different things. You can do arrays and other stuff, but I won't get into that just yet. Where was I? Do want to do one more of these then, and I think that can be the C, that can be the B. Now if we run it one more time just to kind of reiterate over this. It's taking a while. I think that may be because I'm recording now, because it shouldn't really take that long for a simple basic sort of program like this, to be honest. Let's look. There we go. See how it's got a 1 for true. If I put false, it puts a 0 there. So that's, it reads it as an integer value basically, but one that's literally of a 1 or a 0. Okay, so as I was saying, that's the data types. There are lots more, but these are your basic primitive data types that you'll end up using during the course of time. There are other things like vectors and other stuff, but they're all basically array things, and vector would be a vector of something. So it's not quite the same. And structs as well can be a multitude of different types of data types, all as one data type. But these are the primitive data types that you'll be kind of encountering. So that being said, I think now that's pretty much the first part of the data types thing done. That's already itself hit on the 10-minute mark. I did want to kind of keep this to around about 10-minute videos, but I might move on to the size of data types now. So yeah, we'll start on the SizeOf. Now we can work out SizeOf things. In C, it's got a little thing. So if I do SizeOf, so basically SizeOf something will return the size in bytes of it. So if I now do SizeOf B, yeah, now let's have a look. I'm not going to do it that way actually, but even though it would work that way, just stick the two numbers together, which I don't particularly want to do. So what I want to do is the size of a bool is size of B. Okay, so that will actually output the size of the bool data type after typing out the content of the thing. So if I actually run that now, we'll end up with the actual size of the bool data type, which may vary upon systems because they very rarely use like a single bit, because they could theoretically just flip a single bit and flop a single bit to move around, but they tend to in C use sort of an integer data type. I don't know whether it'll be a short or an int, but it'll be interesting to see on this particular system. Funnily enough, wow, it uses 1 byte of data, so 4 bits to hold that. It doesn't need to. So it's basically using a car type, I believe. I'll check in a second to find out. But if I now just keep a copy of this like this and fill in for each of these, right, and change this one to car, this one to short, this one to integer or int, this one to long, this one to float. I'm saying long, it is a long int, but I'm shortening it after that. I might actually say long int just to kind of keep it standardized. And then double. So again, I need to change these. That's going to be C. That's going to be S. It's going to be I. Oh, be careful not to wreck that. It's going to be a L. It's going to be F. It's going to be D. So save those and we'll give it one more quick run. See how that's going. This will kind of display the size of each one in bytes. I could actually have added a little bit onto it to kind of say blah blah bytes or something, but for now I'm just doing this to give you a general idea of what's going on. So it's about to run that, hopefully. It doesn't. There we go, starting up. Okay, so bool and char are both 1 byte. Then short is 2 bytes, 16-bit basically. So 8-bit, 8-bit, 16-bit, 32-bit, 32-bit. Oh, that's why, look, 32-bit. I didn't want to do that. See how it's a long int and it's 4? I wanted that to be an 8, so I need to make it a long. That's why I wanted to know whether that was normal or not. Float is, again, 16-bit. No, sorry, 32-bit. And a double is 64-bit. So 64-bit of size to hold the floating point number. So what I'm going to do is I'm going to change the long int into a long, which should turn it into a larger number. There we go. Save that and run it. That should now be a 64-bit number, hopefully. So I've done that correctly. I'm pretty sure it is on this compiler anyway. I think just a long on a 64-bit system is actually 64 bits, but on a 32-bit system it'll probably be, I can't remember, to be honest, it's been a while since we did. Long data type 8 bytes, that's 64-bit. So that's fine. I think we've got pretty much all of what's needed there done. So I hope you've actually followed me fairly straightforward with this, because the SizeOf is telling us how large in bytes something is. Whatever we press, we can actually just pass it a primitive int, for instance, and that'll tell you how big an int is. It's just sort of used variables, so I've just used them for continual stuff. So it's fairly straightforward, and hopefully you've followed quite well with it. Now I will look at some point why that's doing that, if you know what I mean. I might actually quickly pop on the web and double check that. Right. Come on. How do I display more decimals in the output console? Here we go. Let's see if that works. Set precision. Set precision. Okay. Let's close that for a sec. I've just took a quick look on Stack Overflow, and it's got things saying about set precision. So I'm just going to try it. Let's do, yeah. So I'm going to set precision to 4. Let's give it a go. It may or may not work, but I'm just going to give it a go because I've never used it before. So this is a little bit of a bonus bit to it, but I may need an include for this. Set precision is undefined. IO none IP. Let's have a look. It wants an include. It didn't seem to do it, otherwise. That spelled incorrectly or something. Set precision. That's said correctly. It's still saying it's undefined. What is it with this? I'm gonna take a look and see if I can find out what. Okay,